Let's consider this computer program here, and it's very similar to the one we looked at in the previous video. Now, when we're considering these Python programs, I like to consider an execution space, and in this execution space there will be objects, and these objects message each other. But if we look at the first line of the program, we can see its welcome is assigned the string, and in brackets we can see it has hello world. Now this tells us we're going to be using the string class, which you can see appearing here. And we will now get an instance of this string class, which will have the identifier welcome, because that is as it appears here in the program, and it's going to have the attribute hello world as it appears here in the actual computer program. Now once we've got the object in the computer's execution space, we can remove the relationship diagrammatically shown here, because we're now concentrating on the execution space. Now internally as programmers we have to keep on reflecting back on the string class, because it tells us what the object is capable of doing, because remember it is the template. If we now come onto this line, what this is going to do is simply print hello world, as you can see here. Then we come to this line here, and this line is a message, and we can see it is a message that's going to activate this split method in this object. So we can show that diagrammatically here. And of course what this message is going to do, it's going to invoke the method that we know the string class has, this split method here. And of course what the split method's going to do is going to get hold of the hello world, split it up into hello and world into a list, and we can see that list appearing here, and this list is now going to be returned to be stored in this identifier here. Now in truth what will happen is this identifier words is now bound to an instance of the list class that has as its members hello and world, and it has a length of 2 because it has 2 entries in the list, both hello and world. If we come onto this line, what this is going to do, it's actually going to print that list for us, as you can see here. And you will also have noted that I've removed the message now, because the message is long gone. We've moved on to this particular line here. Now we come on to this line, which is saying the number of words is assigned the length of words. Now remember, words is a list, and inside it has hello and world, as you can see here. And what this is going to do, the len, is going to find the length of this list. In other words, how many entries it has? Well, it has hello and it has world, so that's 2. So 2 will be assigned to number of words. And of course what we then do, we print the number of words to the screen, as you can see here. As an aside, the Python programming language is often referred to as a language that can work in different paradigms. Now one such paradigm is an object-oriented paradigm, meaning you write your programs in an object-oriented way. Another one is often referred to as a procedural paradigm. Now this particular program shows us a line of code that is typical of the object-oriented world, and it's this one here. Because what this is doing, it's sending a message, as we've already shown, and it invokes this particular method here. And of course this method is encapsulated within the actual object. If we look at this line, we're using this here, we're using len. Now that is a function, and what this function will do is do something for us. And a function is like a method, and in fact you could say that a method is a function that's encapsulated within an object, and we give it a special name, method, whereas an actual function like this one is not encapsulated within an object as represented by these diagrams. But it's still the same kind of thing. It'll still do something for us. So the split and the len will have code within them that we don't know how it works, but we just use them because we know what it does. Now we can write our own methods, we can write our own functions, and of course we then need to know what the code does because we're responsible for writing them. But this split one here is one that I know belongs to the string class, and this len I know is one that belongs to the actual language. So to summarize, this is typical of an object-oriented way of writing code, and this is typical of a procedural way of writing code. In an earlier video in the playlist, we looked at this computer program here that allowed the user to enter a sentence, and it counted how many words were in the sentence by counting the spaces between each word and then adding 1 to calculate how many words there were. But it's not a very successful program. For example, what would happen if you had the user typing in a word and then accidentally typing 2 spaces, then a word, and then maybe 3 spaces and then another word? Now obviously, under those circumstances, this wouldn't return the correct number of words. Now we've just been looking at another method of manipulating the string object, and I've produced a program here. And what this does, the first line allows the user to enter a sentence, and then what we do, we split that sentence up, then we find the length of the list that was produced by splitting up the sentence, and then we actually output the sentence and output the number of words in that particular sentence. So let's have a look at these two programs in execution, and we'll see exactly what's going on. Well, here's the computer program here, and what we can do, we can actually run it, and we'll get this, please enter a sentence, and then I'm going to type in Python strings are immutable, and typing this normally here, and now I accidentally hit too many spaces and then type in immutable, and when I get to the end of this particular line I press enter, and we can see that Python has come back by saying the user entered, and it repeats the string I entered with the spaces, as you can see. But if you have a look at the next line, you can clearly see that it hasn't worked out the number of words in the string correctly, and that's because it's counted these extra spaces and then added 1 to all of the spaces that it's counted, and it clearly does not match the number of words that appear in the actual sentence that I typed in. Here's the other program, and if we now simply run this one, what we will get is the please enter a sentence, and I'm going to type in the same thing, Python strings are immutable, and as I'm doing that I'm putting these extra spaces in now, and then I type immutable, and then I'll hit return, and of course when I hit return, Python will output the user entered, and then of course it'll output the string with the spaces in, as you can see. And then if we go on to the next line, you can see that it's actually calculated that there are 4 words in the sentence that I have entered. Here we can see both programs on the same slide, and if we have a look at the first one, you can see here I've got an iteration construct. Within the iteration construct I've actually got a selection construct, and the selection construct looks to see if it's spotted a space. Whereas here, what we've done, we've taken the sentence, we've split it using this into a list, and this line counts how many things are in the list, and that should be equal to the number of words. So the second program didn't have the problem of the user entering more than 1 space between the words. In other words, the split was able to take account of these extra padding spaces, for want of a better word. Now there is a bit more to the split that I'm suggesting here, but we'll look at that in due course. What I wanted to do in this particular video is to show that there is more than one way of doing the same thing, and of course the first method, this program, didn't work 100%. Now I could have altered this, I could have gone and looked and said, well look, if there's 2 spaces we discount 1, but that would start to become a clumsy kind of algorithm. Whereas the second one, that used this split method in a message and used this length function, we were able to do the same thing, showing there's 2 different ways to actually count the number of words in a sentence. And then it just happens that the second one is a little bit better than the first for 2 reasons. One, it's not as complicated looking, it hasn't got these nested constructs that the first one has, and of course it's more accurate in finding the number of words in a sentence. Let's single step through this program to see in fact what's actually happening. Well, when we run the program, we execute the first line of code, which is this one here. Sentence equals input, please enter the sentence. And we will get this appearing. And of course, as a user, I will now enter Python strings that are mutable. And I have not put any extra spaces on this occasion. And then of course we go on to this line, and what it's going to do, it's going to take the sentence that I've just entered and it's going to split it, and it's going to produce a list. And of course that list is going to be bound to this identifier here. The next line takes in the list to this function len. This function then will return to number of words 4. Why? Because when we did this particular line of code, this is what we would have got. Words would have had this list in which we can see that is 1, 2, 3, 4 entries, each word of the string that I actually entered. And of course we then go on to this line here, and of course this outputs the user entered. Then of course it outputs Python strings that are mutable, which is precisely what I typed in. And then it goes on to this program statement, and of course it outputs the number of words in the sentence is, and then of course it outputs the number of words, which we can see is 4, and then of course the program actually ends. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus Circle that relates to these videos.